Hello student, in this video I want to explain the question number 3. So in this question you can see the question on the screen. We are given that f a comma b square bracket to r is integrable, and un and ln, let's denote it. It denotes the upper sum and lower sum estimate of the integral of a continuous function f, this f, using n rectangle of equal widths. So we have to prove that if fn is if f is integrable, then I think I have not written the full question. So this is what we have to prove. u1 minus l u1 minus ln is less than epsilon. We have to find, if f is integrable, we have to find an n which is a natural number, such that for any n greater than n, un minus ln is less than epsilon. Okay, so first we recall the definition of integrable function. So f a b to r is said to be integrable if there exists j belongs to r, such that given any epsilon 1 greater than 0. I intentionally wrote epsilon 1 here because you might get confused with this epsilon and this epsilon, so intentionally wrote it epsilon by 1 greater than 0. There exists a delta 1 for which this condition is satisfied. I mean, the norm of whenever the norm of p is less than delta 1, this delta 1, then this condition is true. And um, let me actually show you the partition actually. So let's say a and b are this one, and suppose for, let's say, epsilon is our 0.5, and according to this definition there exists a delta. Let's say for this epsilon, we get a delta, let's say 0.01. Okay, now this is, let's say, a.01. This one is a.02. Okay, so whatever partition we choose, the condition that it should satisfy is that the delta p is not delta p, this norm of p is less than delta. We are free to choose any partition. It may not be equidistant like this a.01, a.02, equally separated by, I mean, 0.01, 0.01. The norm p is actually the difference between a, if you ask me what is this delta xk. Wait, let me give a set example, and then we will do the question. So delta xk is this one, xk minus 1. So actually you can partition, let's say 01 is my ab. Partition is any x0, x1, xn lying in this 01, such that in this case 01, such that x0 is this one, x1 is this one, sorry, xn is this one, and I can randomly choose. All points will be distant here, and so This is my x1, this is my x2, this is my x3, x4, x5, and and see, this first distance is actually delta x1, because you are subtracting x1 from x0. This is delta x1. This now, this I will show it on different color. This part, this is actually delta x2, because you are subtracting x2 minus x1. You can see delta x1 is less than delta x2. So it may not be equal. You can take any partition. Okay. Then what we are saying is, the norm is, how is the norm defined? This norm delta p is actually defined to be maximum of this delta x k running from 0 to, sorry, k running from 1 to n. Okay, so let me illustrate this. 0, 1, let's say this is 0.1, this is 0.4, this is 0.67, this is 0.89. So x0 is 0, x1 is 0.1, x2 is 0.4, x3 is 0.067, and x4 is 0.89, and x5 is 1. So delta xk is that calculated. Delta x1, is x1 minus x0, that is 0.1. Delta x2 is x2 minus x1, 0.4 minus 0.1, this is 0.3. Delta x3 is 0.67 minus 0.4, this is 0.27. Delta x4 is 0.89 minus 0.67. So what is this? This is 2.22, and delta x5 is 89.11. So you can see, this is delta 1, this is delta 2, delta 3, this is delta 4, and delta 5. Okay, so what is norm p? Norm p is equal to maximum of all this. What is the maximum here? This is 0.3 is the maximum one. Okay, so in this case, so for every epsilon, when we get a delta, we must check that this norm p is less than delta, then this condition is true. Okay, for any partition, you can take any partition, as long as the partition norm is less than delta 1, this condition is true, and you are also allowed to take any ck between xk minus xk for approximate. I mean the where you take the rectangles. I mean the area. You can choose ck, and f. You will get a fck. So you can choose any ck. Just like here for, let's say, for upper sum. What? Let me demonstrate it. Hmm. Let's say our function is something like this. This is function, and this is 0, and this is 1. So my partition be, let's say, same as before: point 1, point 4, point 67, point 89. So now this is my partition. So actually these are not my rectangle where I'm approximating. I will just do dashed line. I mean, like this. These are the partitions. These are the partitions. Now, yeah, so I'm telling you that the condition says that you are allowed to take ck between xk minus 1, any ck. So you might as well take this point between 0 to 0.1. So what is the value here? This is the value here. So you will get this area. Okay. Now, so ck I have chosen c1 in first triangle. I have chosen 0.05. Now c2 must be between 0.1 to 0.4. I can take any value. Let's take let's say c2 is equal to 0.3. This is my 0.3 value here. So this is f of, this height is actually f of 0.3, and the x coordinate is this one. So here we are choosing this triangle. Similarly, you can choose other thing. Let's say I took this one, then this is the rectangle. If you choose this one, this is my area. You can choose, if you here you choose this one, this is the area. You can see that we are making some error, right? let me tell you, this part is little extra, and this part is not covered. This after this, above this purple part, this area is not covered, this area is not covered. So that is our actually epsilon, epsilon 1. That is the error from the actual area. J is the actual area. Okay, so I guess you got my point now. So yeah, this is the definition. I guess I helped you to understand partition. What is a partition? Partition, you can take anything as long as that is less than delta. And I mean the norm. I also explained what is norm. And yeah, ck can be anything between xk minus 1 to xk. And then this condition is true. Then only we say that, I mean, if f is integrable, then this is the condition. Okay. So in this question, we are given that fck, I mean, this function is given to be integrable. So this condition is true. Now now I have explained you all the condition, and we are going to actually solve this question. Un minus ln is less than epsilon. So we are given an epsilon. Okay, we have to find a natural number such that un minus ln is less than epsilon, where n is n in n greater than this capital N. Okay, so now your epsilon is given. I should have written the complete question. Just hang on. Yeah. So now let's see. Okay, so for any epsilon, we have to show this condition. Okay, now if epsilon is greater than 0, epsilon by 2 is greater than 0, then I want to take epsilon 1 is equal to epsilon by 2. So epsilon by 2, epsilon 1 is greater than 0 and f is integrable. Epsilon 1 is greater than 0 and f is integrable. It's given in the question. So this condition is true. This definition. Okay. So now, so that's what I have written. Since f is integrable, there exists delta 1 for every partition satisfying, as long as the partition satisfies this less than delta 1 condition, and ck can be anything. So this condition is true. Epsilon 1 is equal to epsilon by 2. So this is our equation star. Now I am intentionally choosing b minus, you can choose a natural number n such that b minus a by divided by n, this is less than delta 1. Here I am using Archimedean principle, or you can also use the fact that n is unbounded. N is unbounded means that you can actually increase this n, and then certainly you will find after some n that this quantity becomes so less that it is less than delta 1. Okay, this holds for delta 1 greater than 0. So we have existence of such a natural number. Now take any n greater than n. So what we have to remind ourselves, that we have to, for any n greater than capital N, I will show this condition is true. I want to show that. And remember that un and ln, these are actually upper sum and lower sum, and these are, I mean, using n rectangle of equal widths. So you have to remind yourself that. Now I am saying consider this Pn. Okay, a plus b minus a by n, a plus equidistance, a plus b minus a by n, a plus 2b minus a by n, equidistance, a plus k b minus n. Now this is the kth rectangle until b. So all are equally distance. Then the distance is b minus a by n. So delta 1 is delta x2. All these are b minus a by n. Okay. So now what is the norm of this partition? This partition is maximum of this norm is maximum of this delta xk, and all these are equal, so the maximum is this one only, b minus a by n. Now n is greater than capital N here. Okay, so 1 by n is less than 1 by capital N. So now you multiply b minus a, b minus is positive, so inequality won't change, so you will get this, and this is less than delta 1 by here, this equation b minus a by n is less than delta 1. Oh, I should have written delta 1 here. Okay, now see this. So my this pn satisfies this norm is less than delta 1. Okay, so this condition is applicable, right? Because my this chosen pn has less than delta 1, so this condition is applicable, and I can choose any ck between xk minus 1 to xk. Okay, I will choose ck such that ck is actually fck is minimum of f in xk1 to xk. So why can I do that? Because f, we call this we call this theorem, if f a to b is continuous, then the range of f is small m to capital M, where m is minimum of fx and capital M is maximum of fx. So there exists pre-image of f which takes the minimum value, and there exists a pre-image for a capital M where f of that quantity is maximum of fx. So I can do that. I'm doing it for here xk minus 1. The function is restricted to xk minus 1 to xk. So let me draw a diagram to explain it. Let's say this is my xk1, this is my xk. Okay, okay, now so where is the maximum value? Maximum value is of course here. So this is my mk, and where is the minimum value? I think this is my minimum value, and correspondingly this the minimum value for which it takes the x for which it takes mk, this is xk minus 1 is the one, and here it is xk. The graph may not be always like this. Suppose the graph is like this, then mk is this one. Okay, this is xk minus 1, this is xk, so the maximum value is this one. Okay, mk. For that also we have a, this is our ck. Okay, so maximum and minimum value correspondingly there exists ck such that f of ck is mk. So I'm taking that ck in xk minus 1 to xk. Okay, now so this star, if you take fck is mk, minimum of mk, and this delta xk is b minus a by n, right? Equally distance. Okay, so this summation is what? This is ln only. Ln is what? If you divide this a to b into equidistance, I mean using equidistance rectangle, and having the height is minimum value of f mk, and then this is the definition of ln. So this is ln minus j, and this is less than epsilon by 2. I'm using just this thing. Okay, now you choose ck such that fck is maximum of f. Okay, for every k. So this is capital mk b minus a minus j, the same explanation like this. Here we are choosing minimum, and once we are choosing maximum, because we can take any c. Okay, any ck between xk minus 1 to xk. So both this condition are 2, and this is un minus j is less than epsilon by 2. So this is equation 1, this is equation 2. Now un is obviously greater than ln, because un you are taking maximum value, so it is greater than the minimum value. So obviously un minus ln is this one, and this can be written as this so if you take mod of un minus ln, this will return the same value because un minus ln is positive. So now this can be written as equal to un minus j plus j, because minus j plus j, this will is 0, so it won't affect. This is equal to, and now we are using the triangle inequality. What is the triangle inequality? This is the triangle inequality: x plus y is less than equal to mod x plus mod y. You can see in the internet for the proof, or you can read any book, you will find it. So in this case, I'm taking x as un minus j and y j minus ln. So this is mod x mod y. So less than equal to mod x. This is my x, this is my y. So you will get this, and from equation 1 and 2, you will say this one and this one. This is epsilon by 2, epsilon by 2, and this will add to equal to epsilon. So we have proven that un minus 1 is equal to this, is equal to this, is less than equal to this, is less than epsilon. So un minus ln is less than epsilon. Okay, so that's it for question number 3, and thank you very much for watching this.